I'm João Victor, and I'm going to continue from where Selene left the presentation. Well, she has already presented that schizophrenia has some language disturbances that cause structural deficits or structural impairments very broadly. They usually impact functional categories and grammatical operations. In this line of research, there's been an emergence of computational approaches to classifying schizophrenia through language. And this is what we're going to present. We aim at presenting an integration between representing linguistic structure in a way that is aligned with formal linguistics and at the same time using state-of-the-art computational methodologies for natural language processing in order to systematically identify linguistic patterns in schizophrenia. So the first thing I want to present is, well, how to represent language computationally. Nowadays, the state-of-the-art way of representing language is through tokens, because these are the units that are fed to large language models, which are the state-of-the-art algorithms for processing language. Tokens, in the case we're going to present, are very aligned with morphology concepts because they're not entire words and they are not also based on characters, but actually they're based on subwords, which are parts of words that usually represent roots and affixes. These tokens, they are represented as a dense vector of numerical values, and these numerical values are what we call embeddings, and they are what a large language model actually sees and how it conceptualizes systematic linguistic patterns across languages. So these embeddings, they carry a lot of the information regarding linguistic elements that a large language model sees. How does a large language model actually is trained and learns linguistic patterns across a specific language? Well, there's more than one way of doing so, but we're going to introduce the way that BERT does so. BERT is the name for bidirectional encoder representations from transformer, which is a large language model deployed by Google. It is the model we're going to use in our presentation. So BERT takes an input and masks a token from this input, and then tries to predict this token based on its surrounding tokens. And then by adjusting its weights in relation to, well, getting predictions right or wrong, is the way that BERT actually learns patterns and adjusts its embeddings value, the values of its embeddings. Well, a nice part of the pre-training process of BERT is that, well, now it is publicly available as a free-to-use model that comes already pre-trained and that you can fine-tune for downstream tasks. So what we did was we took this model BERT, which was already pre-trained, and we fine-tuned it to classify schizophrenia across a set of 31,278 posts from the social media platform Reddit. These posts were equally split between users who self-declared as having schizophrenia and users who did not self-declare as having any kind of mental disorder. And we chose Reddit because it is already segmented in topics of discussion, so it's easier to find users discussing schizophrenia, and at the same time because it has an accessible API. We manually verified all self-declarations, and we used these post sample, as I have already mentioned, to fine-tune a BERT model, and it achieved an accuracy of close to 70%. Which we interpreted as being suitable for further explorations based on the relation, aiming at analyzing the relation between lexicogrammatical variables across both samples and the BERT's model and the BERT model's classifications, because 70% is higher than a classification by chance, which would result in an accuracy around 15%. So what we did to find correlations between lexicogrammatical variables present in our samples and the BERT model's classifications of schizophrenia was we used SPACY, which is a neural network framework that is publicly available and is state of the art it is an efficient state of the art way of classifying language and processing language in overall. It provides not only grammatical categories, such as pronouns and verbs for words, but it also categorizes dependency relations, such as subject and other objects, complements of a prepositions, and other categorizations. A part of that, we also added external rules to Spacy's inherent classifications to create more categories or refine categories. So, for example, Spacy does not have a representation of bare nouns, but bare nouns were interesting to us. So we added external rules to Spacy's inherent classifications to create this, to check sentence structure and nominal structures and create this new category and called bare nouns. We also created a function that traverses through Spacy's dependencies classifications, and it counts dependency relations in order to provide a measure of embedding depth, which was also interesting to us. And we used such categorizations as variables for further explorations of correlations between their presence and our fine-tuned models classifications. So the most prominent results derived from our set of explorations between lexicogrammatical categories and the model's outputs stem from Markov blankets and input masking approaches. Markov blankets are graph theory approaches in which you try to derive a minimum set of candidate features that can causally account for the prediction of a target variable. We treated the grammatical categories stemming from Spacy and our additional external refinements of its categories as candidate features, and the model's predictions as target variables. And what we identified was that there was a minimum set of predictions of variables that could account for correct predictions of schizophrenia, and they were composed of the following variables: indefinite determiners, first-person pronouns, and overall nouns, and also WH elements. And then we also performed an input masking approach, which was based on choosing a lexicogrammatical categories and substituting it in all samples of our test dataset for the token mask, which is the token that was used during BERT's pre-training. And what we try to see is if the explicit presence of a specific lexicogrammatical category would perturb the BERT model's overall probabilities of samples being related to schizophrenia classifications. And what we observed was that indefinite determiners and the possessive Fs, such as in Lucy's car, were related to prediction of schizophrenia, and also overall nouns and pronominal forms were related to classifications of control samples. Therefore, we can see that there is some kind of alignment between results derived from the literature more aligned with formal linguistics and results derived from computational approaches when we use formal linguistics to refine the computational representation of language, and at the same time to interpret the results derived from experiments that use such representations.